Okay, here's another problem from the textbook. Stone A is dropped from rest down a well, and in 1 second another stone B is dropped from rest. Determine the distance between the stones. Okay, so again, the textbook explains that if you let go or drop an object, it will have an acceleration which is equal to the acceleration of gravity. It doesn't say whether they want newtons or meters or feet, so I'm going to do it in SI units. But anyway, I'm going to draw a picture of it. I'm going to, since I'm interested in the distance or position of objects, I'm going to define an origin. I'm going to, since it's kind of vertical, people like to think of y as being the vertical. I'm going to say at the top of the well is my origin. That's where y equals 0. I have a point A. Starts out at the top. It starts at rest. So they all start at rest, so the initial velocity is 0. I'm going to let the thing go and it's going to fall. And so sometime later it's down here in the well. That'd be after 1 second has occurred. And then at that point, B, which happens to start off at the same location, is dropped, and so it begins to fall down. Okay, so I have I'm going to set my origin. I'm going to define a positive direction. I'm going to let down be positive, so anything that went down is a positive number. And a distance for A is right here. I'm going to call it y, subscript A, and that'll be where stone A is located, and YB is going to be the distance for body B. I'm going to count the degree of freedom, not because it means anything to me yet, but I just want to get practice doing that. The degree of freedom is the number of motions that I have in the problem. In this particular case, I have 2. I have 2 stones. Each one is moving in a single direction, and so there are 2 degrees of freedom of motion for this. So this is a 2 degree of freedom problem. And like I said, it doesn't really mean anything to me yet. But anyway, what I know is that the acceleration of A is equal to a 9.81. That's the acceleration of gravity, 9.81. It'll be meters per second squared. And the acceleration of B happens to be the same thing because I'm dropping them, I'm not touching them, so 9.81. They're both positive because they're both accelerating downward, and that downward has been chosen to be the positive direction. Okay, because these accelerations are constant, I am able to use the handy little formulas from the textbook. Since I'm interested in distance, I really want position. I could care less about the velocity. So I'm going to look in the book for the position equations that relate position, time, and accelerations. And I have them memorized, and so one of them says that the position of body A is equal to the initial position plus the initial velocity times time minus initial time, or when all of the motion started, plus 1/2 acceleration times time minus initial time squared. And a similar equation for body B, which I will write shortly, but I'm going to plug some values in. So what I'm going to do is I'm going to say, okay, well, the position of body A at any time of interest is equal to the initial position. Well, he started at the top of the well, and that's what I'm calling 0. And he starts at rest, so that would be a 0 times time is still 0, plus 1/2 times AT squared, that would be 9.81 over 2. Time is let's see, after another second. So I want to know where they are after 2 seconds. So the time I'm interested in is 2 seconds. The initial time for body A is 0, he started falling immediately, squared. So there's an equation, one equation for one unknown. So I can solve that equation for YA. So basically this will tell me where stone A is after 2 seconds. Now I'm going to write a similar equation for B, and I'll just go ahead and plug numbers in that I know. So position of B at 2 seconds, because this one, by putting in a 2 here, I'm getting the position of A at 2 seconds. I want to know where B is at 2 seconds. So that's equal to the initial value, right? And the body B starts at the top of the well, which is what I've defined to be 0. He also starts at rest, so he has initial velocity of 0. His acceleration is also 9.81 positive, and it's 1/2 of 9.81. His time is 2 seconds minus the initial time. He started moving in 1 second. So that would be 2 minus 1 quantity squared. And so this is a second equation, right? So I have equation number 1, equation number 2. Two equations allow me to solve for two things. The two things are YA and YB. So the distance between them, all I have to do is say, all right, the distance between them is equal to wherever A is, and subtract B. So you can use your calculator and get these values. So that would be, let's see, 9.81 divided by 2 times 2 times 2 squared, excuse me, would be 2 times 9.81. That's where Y is, minus, and this guy would be 9.81 over 2 times 2 minus 1 is 1, squared is 1, so this would be over 9.81 divided by 2. So you subtract that, and that's your distance, which you can use your calculator and get.